Okay, so we're going to look at interchanging between atoms, molecules, moles, and the amount of mass of a substance. And we have this lovely visual here that Seamus gives you, which, for example, if you were trying to find out the mass and you were given a certain number of molecules or atoms, you would multiply or divide in this situation if you're going to moles. So if you're going to moles, you would divide by Avogadro's constant here to get the moles. And then from here, if you wanted to go from, if you had the molar mass, you could multiply by molar mass and you the moles by the molar mass, and you would find the grams. Another way of doing it is just using this visual triangle here. If we're looking for mass, you cover over that. You can work out the molar mass from the periodic table. And remember, we use the periodic table given to us in the back of the chemistry manual and not any other one because this is will get you the right answer in the quiz. So we can use the periodic table to find our molar mass, and we can, if we're given a certain amount of atoms, we can then work this way in direction. So if we have atoms, we're going to divide by Avogadro's constant to get the number of moles. So we're going the other way in this one, and we're just going to practice doing a few questions here. So we're actually given the number of moles on this particular one. So if we're going from moles to how many atoms, in this situation, you can follow the arrow. Sorry, I'm just going to delete this bit here. We're going to follow the arrow. And so we're going from moles to atoms. We're going to multiply by Avogadro's constant. So that's what we're doing. So the answer is simply going to be the number of atoms is going to be 12 by 6.022 by 10 to the 23. And that will give us an answer here of 7.2 by 10 to the 24. You can plug all this into your calculator, and that gives us an answer of B. Okay, we're going to go the other direction this time. This time we're going to have a look at going from, we want to know how many molecules contained. Sorry, we're actually going the same direction here, I think. So yeah, we want to find out how many molecules are contained in 0.75 moles of glucose. And in this situation, we would multiply 0.75 by Avogadro's constant, which is 6.022 by 10 to the 23. And again, this is giving you an answer here, which you can check on your calculator. So it's just going between moles and molecules. In this question here in your journal and in the quiz questions, you want to find out the mass. And this is where we're going to introduce our triangle for the first time. If we're looking for the mass of a certain number of glucose molecules, we need to find out the molar mass and the number of moles that we have. We've been given enough information to do this because we're given the number of molecules. And remember, we can go between molecules and moles here if we divide by Avogadro's constant. That will give us the number of moles, which means we'll be able to tick this one off. We will also be able to work out the molar mass because we're being given the molecular formula here, and we can use the periodic table to find out the molar mass. So we'll have everything we need except the mass to solve for this. So we're going to break it into two steps. First of all, we're going to find how many moles, then we're going to find the molar mass, and then we're going to plug them into our formula. So to go for the first part, we're going to see how many moles are in 7.6 by 10 to the 23 molecules. We're going to divide by Avogadro's constant. And this gives us an answer of 1.2620 moles here. So it's the first thing. We worked out how many moles by dividing by Avogadro's constant. We then read off the molar mass. So we can see that the molecular formula here for glucose is we have 6 carbon, we have 12 hydrogen, and we have 6 oxygen. So we can go to the table, the periodic table, and read off these values here. So we're going to have 6, let's change my pen here. I'm going to have 6 by 12.011, which gives us 72.066. We have 12 hydrogen, which is 1.0079, which gives us 12.0948. And we have 6 oxygen, so 6 by 15.999, which gives us 95.994. And if we add all these together, we get 180.1548 grams per mole. So this is our molar mass. So we now have the number of moles, we have the molar mass, and we can plug them directly into the triangle formula. So the mass is going to be these two multiplied by each other. So we're going to say mass is equal to the number of moles multiplied by the molar mass. And in this situation, it's going to be mass is equal to 1.2620 by 180.1548. And this should give us 227.36 grams. And it asks you here to, it actually doesn't specify how many decimal places on this one.